Welcome to our class today, and today we will have a discussion on a topic by the name Spearmans rank correlation coefficient. So that's what we are going to have a discussion on the Spearmans rank correlation coefficient, and it's going to be in a situation whereby we have not been, whereby we are, where the ranks have actually been given. So that's what we are going to have a discussion in a situation where the ranks have actually been given. So the Spearman's rank correlation coefficient is actually going to explain the degree of similarity between the two ranks. It's going to explain the degree of similarity between two rankings. So that's actually the definition of Spearman's rank correlation coefficient. And the Spearman's rank correlation coefficient is going to be given by the following formula. So this is the formula of the Spearman's rank correlation coefficient. So it's going to be given by this formula. So it's going first of all to be represented by that capital R. Remember we did the Curry-Pearson, which was the product moment correlation coefficient. So the Curry-Pearson was usually being represented by small r. But under this one, under the Spearman's rank correlation coefficient, we are going to represent it with that kind of particular capital R. So the formula is going to be as follows. So Spearman's rank correlation coefficient is equals to, you are going to take 1, you minus 6 summation d squared over n cubed minus n. So that is the formula of that Spearman's rank correlation coefficient. So you take 1 minus 6 summation d squared divided by n cubed minus n. So whereby d is going to be the difference between the two ranks. So whereby D is going to be that difference between the two ranks. So it's going to be the difference between this kind of particular two ranks. And then N will be the sample size. And that the sample size you can actually be able to determine it from this kind of particular question, because the question that we are going to discuss is this question whereby you have been given employees who are ranked. We had rank 1 and rank 2 of those kind of particular 2 employees. And we have to calculate, because the question is saying we determine the Spearman's rank correlation coefficient. And so what we are going to actually be able to do there is that we first of all must be able to establish, we must establish that sample size. And for us to establish the sample size, is just counting those number of employees that we have, which is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is going to be our Spearman's, our sample size in that kind of particular case. So we are going to be able to get the difference between the two ranks, just direct, because in this kind of particular situation, the data that we have been given has already been ranked. And how can we be able to know that the data that we have has already been ranked? They usually give you data that is going to have some smaller figures like 2, 4, 6, 5, you see 8, 7. The highest you see is even 10, sometimes it can go up to 13, 12 there. But if the data that we're going to be given is in huge figures like 50, 120, 150, then again you have to rank it. But in the subsequent videos that I'm going to actually upload here, you can be able to, we are going to have a discussion on a situation whereby now the data that they have given us has not been ranked, whereby we have to be able to rank it. So that is the formula. And again, most of the students are usually confused by extending this dash. The moment you extend this dash to the far end in that manner, then you will be able to get a wrong answer. So you see, this dash is going to start from where we have 6 and then cubed to the far end. So 1 is going to stand alone here. Meaning that when we are going to solve these Spearmans, we must first of all solve this side, and then the answer we are going to get here, we are going to take 1 minus this answer, and then we will be able to have a correct answer there. So do not extend that kind of particular dash to the far end. So that's what you need to again to be able to be reminded. So how do we go about this question? So I have that question there, and the question has employees. We have rank 1, we have also rank 2, and it is saying that where the ranks have been given. So in this case, the ranks have actually been given. Of course, I've told you that in your exam, they will not tell you that these are the ranks, that the ranks were given. You must be able to know, especially when the data figures that you have been given are not going to be such huge figures like 20, 80, 100. So if they are going to be 1, 7, like what you are seeing here, then already it means that the data has already been ranked. And when the data has already been ranked, it becomes easy for us to be able to do that kind of particular question. So what we will be able to do is to add a column. So you are going to add a column of D, and remember D was the difference between the two ranks. So we have to get D squared because of the formula here. So this formula, it requires us to get summation D squared. So that's why, again, we are going to add a column of D squared. So in a situation where the ranks have been given, the columns that you need to add there is D and the D squared, and the D is the difference between the two ranks. So meaning that if I want to get D in this kind of particular case, it's just to take 8 minus this 7, and then I get 1. So that's getting the difference between the two ranks. And then if I want to find the other one, is going to be 6 minus 5, which will also be 1. 4 minus 2, which is going to be 2. And then 1 minus 1, which will be 0. And then we are going to have 3 minus 4, which is going to be negative 1. And then 5 minus 8, which is going to be negative 3. And then we are going to have 7 minus 6, which will be 1. And then we are going to have 2 minus 3, which is going to be negative 1. And then we are going to have 10 minus 9, which will be 1. And then lastly, we have 9 minus 10, which will be negative 1. So now we have the difference between the two ranks. The next step is to find the D squared. And how do we find D squared? So D squared is going to be, we are going to square this D that we have actually calculated here by taking the difference between the two ranks, which was rank 1 minus actually rank 2. So D squared then becomes 1 squared, which will be 1. This 1 squared, which will be also be 1. 2 squared, which will be 4. 0 squared, which will be 0. Negative 1 squared, which will be 1. Negative 3 squared, which will be 9. And then 1 squared, which will be 1. Negative 1 squared also, which will be 1. This 1 squared here, which will be 1. And lastly, negative 1 squared, which will also be 1. So we need to find, we're going to find the summation of that column, because the question requires us, the formula requires us to have the summation D squared. And how can we be able to get the summation D squared? Is by adding this column of D squared. And if you can be able to add this kind of particular column, it's actually going to be 9 plus 4, which will be 13. So 9 plus this 4 will be 13. Let us count the number of ones we have. You can be able to see we have 1, 2, 3, 4, 5, 6, 7. So 13 plus 7, which is going to be 20. Meaning that summation D squared, which we have been looking for, is going to be 20. So we are going to have 20 there, the summation D squared. And the moment you have that summation D squared, you will go ahead now to apply that kind of particular formula. So let us now apply this formula here. So in order to apply the formula, we are going to apply it as follows. So our rank is going to be 1, minus, so 6 is always a constant and it will always be there. So 6 is part of the formula. So it's going to be a constant that will be part of this formula wherever you're going to apply it. So it's going to be 6, and there's this dot here which is going to show that we are going to have a multiplication. So it's going to be 6 multiplied by summation d squared. Summation d squared is what we have actually calculated here. And summation d squared is this 20. So it's going to be this 20 over n cubed. N cubed, remember we said n is the sample size, and the sample size is just counting this number of employees that we have here, which we said is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10. So sometimes they may not give you these employees, they can just go direct and give you the ranks. So you are going to count one of it. Even if you count this one, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how you get the sample size. And in this case, the sample size is 10. So from the formula, they are saying that that sample size should be cubed. So it's going to be 10 cubed minus n again, which is the sample size. And the sample size is actually 10. So that's what we want to do there. So then next is going to be, so still we want to get our rank correlation. So it's going to be this one minus. I told you that this dash should not be extend to the further end there, because you will get a wrong answer. So we must solve this part first, and then we take this one, we minus that answer, we get our rank, the Spearmans rank correlation coefficient, in that kind of particular manner. So it's going to be 6 times 20, which is going to be 120 over 10 cubed. If you just take 10 cubed using your calculator, you will get is actually 1,000 minus this 10. So which is going to be 1 minus 120 over 990. So you see, we are almost getting the answer there. So which will be 1 minus, so I want us to, you take your calculator, and then you take 120 divided by 990, so that we see how much we are going to have. So if we take that 120 divided by 990, then we are going to have 0.12. So let me put it up to 4 decimal places. It's always advisable to have your answer in 4 decimal places so that you get the most accurate answer there. So after getting that one, we are going to take 1 minus this 0.1212, which is going to give you a rank. So your rank is going to be 0.8788. So that's how you get the Spearman's rank correlation coefficient in a situation whereby the ranks have actually been given. So that's how we calculate it. So in the next video, we are going to calculate the Spearman's rank correlation coefficient in a situation whereby you have not been, the data that you have been given has not been ranked. So whereby we have to rank it first before calculating the Spearman's rank correlation coefficient. So for today, this is what we were supposed to do, and I hope you have deciphered that kind of particular information in detail. So thank you. We meet for the next class.